Namaste students, welcome to my channel Sumanth Tutorial. I am very thankful from the bottom of my heart those who have subscribed my channel, and I request you people to subscribe if you have not yet done and click on the bell notification, and finally don't forget to like, comment and share. Thank you. In this session, I am going to explain you the concept of some terms related to the motion. That is, under the chapter Motion in One Dimension, the part A. Yes, students, so let us begin. See here, first we are going to study the concept about the physical quantity. The quantity which are measurable are called as physical quantity. I repeat, the quantities which can be measurable, that all comes under the physical quantity, and this physical quantity that has been classified into two forms. One is the scalar quantity and the another one is the vector quantity. So let us study what are those things. So let me take it as scalar. Means the quantity which can be measured only by its magnitude but not direction. I repeat, the quantities which are measured only by its magnitude but not its direction, that is called as scalar quantity. For example, you can take mass, unit is kg. So if you want to measure its mass, we need its magnitude. How much the mass is, that is enough, direction is not required. So find out the temperature is the scalar quantity and the unit is Kelvin. So it is very clear that to measure this mass and temperature, we need only its magnitude but not the direction. So the quantities which can be measured only based on its magnitude, that is called as the scalar quantity. Now the vector quantity. The quantity which can be measured in both magnitude as well as direction is called as the vector quantity. Means here, if you want to measure the vector quantity, we need both magnitude as well as direction. For example, velocity. Velocity, that is nothing but the unit having meter per second, or displacement force. Displacement unit is meter, force is Newton. So if you observe these example, so it is very clear that the quantity which has both magnitude as well as direction, that can be categorized under the vector quantity. See here, the force F with this arrow mark, or V with this arrow mark, or acceleration this arrow mark. So it is very clear that to represent this vector quantity, we are going to use this arrow mark. So anyway, if you observe the physical quantity marked with this arrow mark, that indicates that it's an vector quantity. Now the concept of rest and motion means, if the object is at rest or object is at motion, how we can define it? It is very simple. If the position of the object remains same with respect to the time and the immediate surrounding, that condition is called as the rest position. If you want to say the object is at rest, it is very clear that the position of the object remains same with respect to the time and the immediate surroundings. If it is keep on changing, if the position of the object is changing with respect to the time and the immediate surroundings. That condition is called as motion. So you can easily define it. The position of the object remains same. Here the position of the objects will change with respect to the time and the surroundings. For example, a book lying on a table. If a book lying on a table, it's an example for the body at rest, because as the time passes, the position of the book remains same. It's very clear. The second one, a car is moving on a road. If the car is moving on a road, the position of the car is keep on changing. So that condition is called as motion. Now, motion in one dimension. If the object is moving in a straight line, that motion is called as motion in one dimension. It is very simple and very clear. If the object is moving in a straight line, that condition is said to be motion in one dimension. If we plot a graph of position versus the time, if we get a straight line over there, that indicates that the motion of that object in a straight line. Observe now. Position of an object with respect to time. When the time is 1 minute, 2 minutes, 3 minutes, 4 minutes and 5 minutes, and the position of the object is 2 meter, 4, 6, 8 and 10. I said position in terms of meter and time in terms of minute. So if I plot a graph now, that is position with respect to time. Position with respect to the time. So what's the position value is 10, that is 2, 4, 6, 8 and 10, and now the time is 1, 2, 3, 4 and 5. If you observe, we will get a straight line. See here, 1 second, 2, 4, 6, 8 and 10. See here. By observing this one, it is very clear that the motion of an object is in a straight line. That comes under the category of one-dimensional motion. Now, the distance traveled and the displacement. In my previous video, it was very clearly explained to you the concept about the distance traveled and displacement. So here I am going to tell a very basic thing. That is, the distance traveled is the actual path traveled by an object, and the displacement is the shortest distance. So distance traveled is the actual path and the displacement is the shortest distance. Both are measured in terms of meter. So it is very clear that distance traveled and the displacement both are measured in terms of meter, but distance traveled is a scalar quantity whereas displacement is a vector quantity, because direction is very important. And one thing, that distance traveled cannot be negative or zero, but there is a chance displacement can be negative or zero. For example, if you take a circular path object is moving in this direction, come back to its original position, the displacement is 0. And direction may be clockwise or anti-clockwise, that may be the negative, but those things cannot be happened with respect to the distance traveled. So it is very clear that distance traveled is a scalar quantity, displacement is a vector quantity. Yes students, let us study about speed. The definition of speed says that speed is the rate of change of distance traveled with respect to time. So how we can represent? We can represent like this: V is equal to S divided by T. T represents the speed, S represents the distance traveled, and T represents the time. So speed is equal to distance traveled divided by time, and it is a scalar quantity because direction is not required, only we are going to find out its magnitude. Now the unit of speed. So the unit of speed is the unit of distance divided by unit of time, that is meter per second. We can also represent it as meter second inverse. So the SI unit of speed is meter per second. But in a speedometer, you might have observed the unit is given in kilometer per hour. This is also the units, but not the SI unit. How to convert kilometer per hour to meter per second? That we are going to discuss at the end of this session. So with this formula we can find out its distance traveled also, that is S is equal to V into T. So with the help of S is equal to V into T, we can find out the distance traveled by the object moving with the speed of V in a time T. Now uniform and non-uniform speed. You have already learnt what is uniform and non-uniform motion, like that throughout the motion of the object, if the object covers equal distance in equal interval of time, that is said to be uniform speed. How it is possible? Imagine that the ball is moving in a frictionless motion. That motion is said to be a uniform speed. If the distance is keep on changing with respect to the time, means it is very clear that if the object is moving unequal distance in unequal interval of time, or if the object is covering unequal distance in unequal interval of time, that speed is said to be non-uniform speed. Example you can give: the vehicle is moving in a crowded area, or the vehicle is moving in a traffic. There we can observe the non-uniform speed. So instantaneous speed. If we are measuring the speed in a very short duration of time or short interval of time, that speed is called as instantaneous speed. So we can observe this instantaneous speed in a speedometer of our vehicle. The meter reading which is observing when we are going to driving our vehicle, that is called as the instantaneous speed. Average speed. Average speed says that the total distance by total time taken. So average speed is the ratio of the total distance traveled by the object divided by the total time. That is called as the average speed. The total distance traveled by the vehicle in a given total time. That ratio will going to give you the concept of the average speed. Now, velocity. Velocity defines that the rate of change of displacement in a given time. Velocity defines that the rate of change of displacement with respect to the time. So V is equal to S by T. Speed and velocity looking like same. What we should add now here? Very good. The direction. See, I said very clearly the direction represents the vector quantity. So this velocity is a vector quantity as it is the ratio of displacement with respect to time. So this velocity is a vector quantity but unit remains same, meter per second. To find the displacement, we can use the formula velocity into time. Just like speed, in velocity also we are having uniform velocity. For example, a raindrop is reaching the earth's surface. If you observe a raindrop which is reaching the earth's surface, the motion is said to be a uniform velocity. So non-uniform velocity, one of the best example, that is the object is moving in a circular path. Very important one. If the object is moving in a uniform circular path, here the velocity is keep on varying. The speed may remains same, but the direction is always changing in every instant of time. In this case, the velocity is non-uniform. The average velocity, the total displacement by total time taken. So in a speed we learnt the total distance traveled divided by total time taken. Here the average velocity is the displacement divided by the total time taken. Now the concept about acceleration. So it defines that the rate of change of velocity with respect to time. So acceleration is equal to the change of velocity divided by time. That is acceleration, and obviously this acceleration is also a vector quantity. If I say there is a change in velocity, then we should have two velocities, that is initial velocity and final velocity. Initial velocity is represented in U, and the final velocity V. Change means subtract. So it is very clear that A is equal to V minus U divided by T. This is the concept about your acceleration, change in velocity with respect to time. And the unit is meter per second square or meter second inverse square. Now a very important one, that is acceleration due to gravity. Means if a body is attracted towards the earth's gravitational force, if it is coming towards the earth's surface, it gains some acceleration. I repeat, all freely falling object, when it is comes under the earth's gravitational force of attraction, it gains some acceleration. That acceleration is called as acceleration due to gravity. For earth, the acceleration due to gravity G is equal to 9.8 meter per second square and very nearly equal to 10 meter per second square. Yes students, if you are very clear with the theory part, let me solve few numericals based on the content. The speed of the car is 72 km per hour. Express it in meter per second. So what it is given? speed is equal to 72 kilometer per hour. We need to represent in terms of meter per second. So we know very clearly 1 kilometer per hour will be equal to 5 by 18 meter per second. So this is the standard one. If you want to represent kilometer per hour in terms of meter per second, you need to multiply it by 5 by 18 times. So 72 kilometer per hour will be equal to 72 into 5 divided by 18. So 18 fours are, it is 20 meter per second. Second one, express 15 meter per second in terms of kilometer per hour. Here they had not specified anything, just they said that 15 meter per second in terms of kilometer per hour. Write down 1 meter per second will be equal to 18 by 5 kilometer per hour. Reverse of it. That's all. Kilometer per hour to meter per second, 5 by 18 times. Meter per second to kilometer per hour, 18 by 5 times. Then 15 meter per second will be equal to 15 into 18 by 5. So 5 3s are 15, 18 3s are 54 kilometer per hour. Yeah, next question is 1 kilometer per hour in terms of meter per second. To which 1 kilometer per hour will be equal to 5 by 80 meter per second. Convert that one to decimal. When you divide 18 and 5, 0.27 meter per second. Yeah, students, I hope you like this class. If you like, then what you are waiting for? Please subscribe my channel. Along with that one, don't forget to like, comment and share. Thank you.